teacher. I am Sanyam of class 11 Science A. I am here going to present my presentation on the topic Carnot heat engine. Without wasting much of your time, I am directly going on towards my topic. Heat engine. What's a heat engine? It can be simply defined. Heat engine is a device which can convert heat energy into a mechanical energy. Heat engine have three main components such as source of heat, a source which provide heat or energy to a heat substance that burns and provide energy to a heat system, which is also have the higher temperature. Working substance, it is a place where work take place or heat energy converted into mechanical energy, and a sink of heat engine where temperature is down. Without wasting, directly going to a topic. In a heat engine, heat engine act as the working substance. Its efficiency is 30% to 40%. Remember, there is no heat engine, no vehicle which have efficiency of 100%. Even in the petroleum car, etc., have efficiency of 30 to 45%. In Carnot, as well, I am going to directly towards the Carnot. Carnot said that the Carnot heat engine have the efficiency of directly 100%, which means the value of mu equals to 1, which can't be possible because for that we need the source of heat which have infinite number of energy and the sink of heat which have infinite number of insulator and infinite number of conductor, which cannot be possible in the reality. Its working efficiency is more than 100%, because other factors like we can say friction, aerodynamics, the pressure of air, the friction inside the piston, the friction from the tracks, etc., play a major role in the reducing the efficiency of Carnot engine. Thank you. Carnot engine, you can see the source here, provide the temperature T1, gives the energy Q1 to the working substance, provide the work done, and that rest of the directly go towards the sink with temperature T2. Now, without wasting much of the time, we are directly jumping towards the Carnot heat engine. Carnot heat engine. This heat engine is not possible in reality because it has the efficiency of 100%. That cannot be possible. But it lay the foundation of the working engine that we use today in a car, in the train, etc. Today, let's hear how to derive the formula. Q1 equals to amount of heat in a produce, amount of heat given to an engine. Q2 amount of heat rejected by the engine, and here W equals to work done. We know that from the small change in energy equals to energy provided minus energy reflected. So we can say in a working substance return to its original state because the cycle, as we studied earlier in the sessions here. So we know the change in internal energy is equal to 0 because working substance returns to its original position. So we can know that dq equals to small change in energy equals to small work done plus small change in internal energy. As now, here when dun is initial energy is 0, so internal energy is 0. So we can directly say that dq equals to dw, small amount of change in energy. Small amount of energy change equals to the small amount of work done. Now we can say that, or you can say Q2 minus Q1 equals to dW because we know small work done equals to small change energy. So dq equals to dW. Now therefore, sorry blocking this one. Their thermal efficiency. It is defined as the ratio of the net work done per cycle. Ratio of the net work done per cycle by the engine towards the total amount of heat absorbed per cycle by the working substance from the source. It is denoted by the coefficient of thermal efficiency is known as eta, N type. You see here. Now we can say it is What I can explain, you can understand that it is calculated total amount of work energy provided upon the total amount of work done by the engine or system. You can say this is why we can define find the thermal efficiency. मतलब the how work, how thermal, how can we say how much amount of work done, or you can say how much work done by the engine according to its the energy provided by its source Q1. You can say here eta. Eta is also known as thermal efficiency constant. Now we have come to the end of our exclusive and happy, very exciting lecture. At last we can know that now eta equals to net amount of work done per cycle. Remember, net amount of work done per cycle by the total amount of heat absorbed by the engine per or working cycle per cycle. Per cycle, remember that. Now the eta or equals to Q1 minus Q2 upon T1, because net work done. We know that the dW equals to dQ. Remember, dW equals to dQ, and dQ equals to Q1 minus Q2, heat provided minus heat reflected, upon Q1. So total amount of heat is Q1 and the heat reflected Q2. Now here, so we can find the efficiency or eta of the by the formula 1 minus Q2 upon Q1. This is a basic maths, you can say, or we can also get a derive another formula by substituting the Q1 or Q2 by the temperature, because temperature is directly proportional to the heat provided by the energy provided by the system. So eta equals to T1 minus T2. Remember, T1 minus T2, amount of temperature given minus amount of temperature absorbed, T1 minus T2 upon T1, total amount of energy means total amount of temperature given. So we can also say eta equals to T2 minus T1 here. Thank you sir.